So today we are going to tackle a really fascinating looking equation that involves the variable p. Specifically, p plus p divided by p is equal to p. And while this might seem like elementary school math at first glance, I promise you there is a hidden trap here that trips up even the smartest students. So before we jump into the nuts and bolts of solving this, please do me a huge favor and click that subscribe button and give this video a like, because it really supports the channel and helps us bring more math content your way. Now, to really understand what is going on here, we are going to explore two separate paths to the solution, and I want you to watch closely, because the first path is going to lead us to a very specific number, but the second path is going to show us the reality of the situation, and comparing them is where the real learning happens. Let's kick things off with the first method, which is the standard algebraic approach where we try to manipulate the equation to find a root. If you focus your attention on the left side of the equation, you will notice the fraction p over p. We know from our basic arithmetic rules that any value divided by itself simplifies to 1, provided that value isn't 0. So we can rewrite our equation much more simply as p plus 1 is equal to p. Now, looking at this, your intuition might already be screaming that something is off, but let's ignore that feeling for a moment and try to solve it mathematically by using a technique called squaring. If we square the entire left side, which is the quantity p plus 1, and we also square the right side, which is just p, we are keeping the equation balanced, giving us p plus 1 squared equals p squared. Now, we need to expand that left side. And remember, when you square a binomial like p plus 1, you don't just square the parts. You have to multiply p plus 1 by p plus 1, which gives us p squared plus 2p plus 1. And all of that is still equal to the p squared on the right side. This is looking good so far, but now we want to isolate our variable. So let's try to get all the p terms together. If we subtract p squared from both sides of the equation, a really convenient thing happens. The p squared terms on both sides completely cancel each other out, and they vanish, leaving us with a much simpler linear equation, which is 2 times p plus 1 is equal to 0. From here, it is a straight shot to the answer. We move the positive 1 over to the right side where it becomes a negative 1, giving us 2p equals negative 1, and then we divide by 2 to get p is equal to negative 0.5, or negative 1/2. So we have an answer, right? Well, not so fast, because in math, finding x or p is only half the battle. We have to verify it. So let's take this value of negative 1/2 and plug it back into our very first equation to see if it holds water. The equation was p plus p over p equals p. If we replace every p with negative 1/2, the left side becomes negative 1/2 plus 1, because remember that fraction simplifies to 1, and negative 1/2 plus 1 equals positive 1/2. But, and this is the big but, the right side of our equation is just p, which is negative 1/2. So we have ended up with a statement saying positive 1/2 is equal to negative 1/2. That is obviously incorrect. A positive number cannot equal a negative number of the same magnitude. This tells us that negative 1/2 is actually an extraneous solution, which is just a fancy way of saying it's a ghost answer that appeared because we squared things, but it's not actually real. Since that road led to a dead end, let's look at the second method, which relies on pure logic and is much faster. Let's go back to that simplified step where we had p plus 1 is equal to p. Now, think about this logically. If you have a number p and you add 1 to it, can you ever get the same number p back? If we try to solve this by subtracting p from both sides to group our variables, the p on the left and the p on the right cancel out completely, and we are left with a statement that 1 is equal to 0. This is a classic mathematical contradiction because 1 is definitely not 0. When you reach a contradiction like this, it is the universe's way of telling you that the original premise was impossible. So what is the final verdict? Because our algebraic root failed the check and our logical method led to an impossibility, we can confidently conclude that there is absolutely no solution for this equation. It was a trick question all along. I really hope you guys enjoyed this walkthrough and seeing why we always need to check our work. So please make sure to subscribe if you haven't already and drop a comment below if you have any questions or if you want to suggest the next problem for us to solve.